tonight. The thing I'd like to maybe point out to some of the folks in the chat here, or whatever you want to call it, is I did return test 1 corrections. And so I graded it through this website that allowed me to use a rubric and basically point out to you on various problems where you may have lost points. And so I emailed those results to you via the website Gradescope. And so you would have gotten a web or a link from that website that you can log in and check your scores. And I'm able to see who has looked at their scores or their tests yet, and it looks like about half the class hasn't done that yet. So you don't have to, but if you're interested in where you lost points or you want to talk about any of that material, you have questions about it, please do check that out. I then posted solutions to Blackboard, so that's in a separate location. I plan to do the same thing for the final. And that's, just to be clear, that's why I'm being so like uptight or anal about these scans, is because in order to use that grading website, the scans need to have the same number of pages, and it needs to be in the rough correct order and things like that. So that's why I was trying to be very uptight about that. I've mentioned this before. There's been a couple more questions. Our final exam, I'm hoping to do during our normally scheduled final exam time. So if we still had final exam week, this is when our final exam would have been. And I was instructed to try to use that time for our final. I think it's going to be a little bit of a mishmash going on at the end of the semester there, because I imagine some classes may not be doing finals, and so I could imagine that maybe this would interfere with some live class potentially. So I'm trying to tell people as early as possible. That's why I told you a couple weeks ago even, just so you can figure out if you might have an issue with that. We can adjust if needed. But that's sort of what I was told to do, and so I'm going to try to do that. But let me know if that's a problem. I got at least 4 questions about homework. I'm happy to go over those problems. And if other people have questions, we could do that as well. I'm not remembering off the top of my head what video was due for today, but I did get some questions about some of the homework due tonight, and so we can look at that. Any questions about the test or anything like that before we look at some of the material? Okay, so I will go over to some of these homework questions. So 4.1 and 4.2, I believe, are the homeworks that are due this evening. I had this question from 4.1, which we had actually looked at previously. And so in one of my previous videos, I did go over this question, although when we went over it in class previously, it looked a little bit different. So it looks like whoever asked this question, they had a slightly different problem generated, but it's a very similar solution. Let me pull out the notes so I can point out it real quick. So these questions are about vector spaces and subspaces. And for subspaces, which is a subset of a vector space, we need to show these 3 things. And so in these problems, they're walking you through these 3 things. And if all these 3 things are true, you have a subspace, right? That's the idea. And so the idea is if the 0 vector is in the space, if it's closed under addition and it's closed under scalar multiplication, then you have a vector space. And so that's why you do those 3 things. And then the last thing you do is you choose if it's a subspace. And so in this particular subspace, it's like the 3rd quadrant in R2, right? The one that's highlighted right here. Let me let it focus here. And so things in this quadrant are characterized by this, right? Both they're ordered pairs, x comma y, where both of the things are negative, right? If you want to be down in that quadrant, then you need to have both the values negative. And so, or less than or equal to 0, which is important for the first part, because is the 0 vector in there? The answer to that one's yes, because technically the way this is defined, it's including the 0, right? And so 0, 0 is in the set, right? So this one is a yes, and it's like a drop-down menu. And let me remind myself what the options are. I think one of them just says like, yes, 0's in there. Either says H does or does not contain the 0 vector. So it does contain it in this case. And anyone stop me at any time here. is it closed under addition? Well, let's just pick two values. So let's let x1 be x1, y1, and x2 be x2, y2, and let those be in the set. Well, if those are in the set, then x1, x2, y1, y2 are all less than or equal to 0. Right? If in this quadrant, everything's negative. And if we add those two things together, we get things that look like this. And since the individual things were negative, the sum of them is negative, right? In other words, if you add two vectors in the set, they stay down in there. And so still in quadrant 3. And so is it closed under addition? Yes, it's closed under addition. So being closed means if you have two things that are already in the set and you add them together, it stays in the set. That's what it means to be closed. Now the third part is what fails. So we have a yes for this one, so it looks good so far. Yes for this one, looks great. If we get a yes for this one, it's going to be closed. But this one is not closed, right? So scalar multiplication. So let's look at that same vector again. x1, y1. So that's the same thing. Both those values are negative. If you multiply this by a constant, it becomes this. And if this is closed, then those values need to still be negative. But C is any number, even a negative one. And so if you multiply by a negative number, right, so if this is the vector right here, and you multiply it by a negative, it flips it around and goes over this way, right? So if that's u, this one is minus u. And so if C is negative, then CX1 is not in the set. And so this one is not closed under addition, multiplication, excuse me. And so we get a no for this one. And so because if this one's a no, we need them all to be yes for the last to be yes. So is it a subspace? No, because 3 failed. And so it was closed on two of the three things, or two of the three things were satisfied, the properties, but since the third one was not, it's not a subspace. Thoughts about that one? Okay. I got another repeat question. So this someone else asked about number 15, which I also did previously during class. And so I'm not going to say too much about this one because I'm hoping that the last one reminded you about how this worked. I did 15. I don't know when we did this one, but if you want to look back at one of the YouTube videos, you can see the detailed explanation. I'm just going to sort of quickly talk about this. So this one says we're talking about all matrices such that when you raise it to some power, you get the zero matrix, right? And so is the zero matrix in there? Well, sure, because if you have the zero matrix, which looks like that, and you raise it to any power, like the number 1, it stays a zero matrix, right? So the zero matrix satisfies this property, right? You can just see that. And so does it contain the zero vector? Yes. 3 is also a yes. I'm going to skip 2 for a second because that ends up being a no, but let's talk about the yeses for a second here. Actually, am I looking at the right problem here? Oh, sorry, I had the wrong problem up on my computer. I got confused for a second there. Right. So 3 is also closed. So is it closed under scalar multiplication? So this one we had seen, let's suppose that a to the n equals 0. Well, when you do c times a, and you raise that to the nth power, that's the same thing as c to the n, a to the n. And we know this one equals 0. And so this ends up being c to the n times 0, which is 0. And so this one is closed under scalar multiplication as well. So we get 2 yeses on this one, just like we did on the last one. But number 2 fails. And this is, if you remember, I had messed this one up when we originally talked about it. And then I corrected it next time. So this one is a no in part 2, because for the example, this matrix, oops, that should be a 1. This matrix squared is in the set because you get the 0 matrix. And this matrix squared is 0, so that's in the set. All right, so I'm choosing 2 matrices that are in the set, but when you add them together, you get a matrix that's not in the set. No matter what you raise to that to the power, you're never going to get 0, 0, 0, 0. And so on this particular one, you need to enter a counterexample. And the counterexample you might want to enter would be this matrix and this matrix. I did do that in a little more detail in another video if you wanted to see that, but I guess I kind of just did that one too here. Questions about that one at all? Want to clarify anything there? Oh, and so finally, is it a subspace? The answer is no, because 2 failed. Right, you need them all to be true for it to be a subspace. All right, I'm going to assume everything's okay and that you can hear me. And I'm going to keep going. I had another question about the next one. Problem 16. We have not looked at this one yet. And so let's look at this one a little more carefully. So in this particular set, we are looking at all matrices where the trace is 0. So it says the sum of the diagonal entries, which is known as the trace, is 0. Is that what it says here? Let V be a vector space of 2 by 2 with real entries. Let H be the subspace with real entries that have trace 1. Sorry. So in this particular space, let's say we had A, B, C, D. So we're in 2 by 2s, right? If you're in H, then A plus D has to equal 1. That's the definition of this spaces. And so, I particularly, let me also just mention, I particularly picked 15 and 16 to be a little bit trickier because I wanted you to think about these in a slightly different context instead of Rn. So these last couples were related to the matrix spaces, which I don't know, which I think are cool. So anyway, is the 0 vector in there? So is 0, 0, 0, 0 in the space? I think I'd like a little more participation here just to make sure that people are with me. Is the trace of that thing 1? Feel free to speak up or type. I'd love to hear your voice.
Is it not in H?
No, because 0 plus 0 does not equal 1. Right? When you add up the diagonals on this one, you don't get 1. So does it contain the 0 vector? No. And this one was already selected when I printed that one out. Is it closed under addition? So if you had suppose you had 2 vectors, A, B, C, D, where A plus D equals 1. Let's call that vector. Should have given myself some more room here. I'm going to do it down below here. Let's create 2 matrices in the set. So let's let A be this matrix. I'm going to do it in general, and then we can pick out a specific example. And let's say that's in the set, so A plus D equals 1. And let's pick another one in the set. Let's call it E, F, G, H. And let's say E plus H equals 1. So those 2 are in the set, right? We're picking 2 arbitrary matrices that are in the set. Well, when we add them together, we'd get this. And if we add that trace together, that's that first entry plus this one, what do we get? You can rearrange this into this, in other words. Right? Sorry, that should be E. What does that equal? They each individually equal 1. And so together they equal 2. In order to be in the set, they need the trace needs to equal 1. Right? So when you add two things together that have a trace of 1, like this, you end up with a trace of 2. And so this is not closed under addition. And so you would need to pick up two examples, just pretty much any two matrices in the set. Any two matrices in the set, when you add them together, are not going to be in the set. So you just need to figure out a counterexample now on this one. So the answer is no, but you need to figure out a counterexample.
It's also not closed under scalar multiplication, from what I remember.
True. Yeah, so it's also not closed on the third part either, because if you had, I'll just give you a counterexample in this one. This is something in the set, right? Because if you add 1 and 0, you get 1. But if you multiplied it by 2, all of a sudden the trace would be 2, right? And this is not in the set. So yeah, 2 and 3 fail on this one, which is why overall the answer is a no as well. Questions? So between these three and the ones I've done previously, so if you look back at past videos, I just got some of the papers out in front of me. I also did number 5 in this set. I did number 9, 8, and 10 in this set. So we've done almost all of these problems together. I did number 6 in this set. I noticed this was a particularly tricky set, especially the way that it was set up. I know that you had to answer these questions, and it might not have told you what was right and wrong and stuff. So anyway, I'm just trying to say all the answers are out there, both either in the notes and or in the videos. Most of the answers, I should say. So if you're stuck on these later, I would suggest looking back at some past videos and notes. Are there other questions about 4.1 that you guys want to talk about right now? Okay. I also have this question from 4.2. And let me just pull out the 4.2 notes quick as well, because I want to just remind you what a null space and the subspace are. So the null space are all matrices X that when you multiply them by A, they get sent to 0, right? And so they're things you multiply by A and they get sent to 0. The column space is just the span of the columns, and so any linear combination of the columns, right? And so if we're thinking about null space versus column space, let me do this on another piece of paper here. So A is an m by n matrix, and null space are x's such that A times x equals 0. And so that means if A is m by n, then x's have to be n by 1. Right? That's the size of things in the null space. Just want to sort of clarify that, because that's part of this homework, and this particular question is asking you basically how big are the vectors in the null space. And then the m tells you the number of rows, and so this value here tells you the size of the columns. right? So in other words, the columns are m by 1. And so that's the size of things in the column space. So the m tells you the size of things in the column space, and the n tells you the size of the things in the null space. Is that okay? Because the first question on this one, this is the first problem in 4.2, is it gives you a matrix A, and then it wants to know the size of the vectors in the null space and the column space. So A, I know this is kind of hard to see, but A here is a 4 by 2. And so this is the size of the columns, and this is the size of the null space. And so find a case such that null space is a subset of that. So that would be 2. And find a case such that column space is a subset. So that would be 4. Again, this is the dimensions of the matrix. I did see that. Finton just asked a question. Let me see what that said. Is row space just column space but applied to the rows? Yes, that's exactly right. Row space is the same thing as column space but applied to the rows. Excuse me.
Professor, does that mean it's just a linear combination of the rows for the row space?
Correct.
Okay.
Yeah. So row space of, this is matrix B that they're asking row space about, is, like you said, linear combination of the rows instead of the columns. Now this is a weird matrix in this particular one because this B is like, it's a vector technically, but you can think about that as a 1 by 5 is a 5. Yeah, 1 by 5. And so the rows, there's only one of them, and it's size 1 by 5. And so yeah, this one's a little bit trickier. Let me make sure I'm thinking about this right. And I apologize for not. There's nothing about row space in the textbook, and I always thought about like, should we cover this? Should we not cover this? And I never actually did. Yeah, that's right. So this is a little bit different then because the null space still follows this, right? So if you were going to do bx equals 0, then this is a 1 by 5, and so x should be a 5 by 1, and so things in the null space should be 5 by 1s, but things in the row space are also 5 by 1s because they're just rows, right? So this is the size of the rows. And so I guess if you're talking about row space, the column space and the null space will be the same. Yeah, I don't put things about row space on tests. I follow the book on tests and things like that. These questions in the homework don't follow the book, right? I just pulled them off this website. And so they had some stuff about row space, and I thought it was worth just leaving it there. I thought, it's not that big of a stretch to go between row space and column space, I thought. And so on the last one, C here is a matrix that is 4 by 3. And so again, this is going to tell you the size of both the null space and the row space, it turns out. And this tells you the column space size. So this would be a 4. This one would be a 3. Questions about that one? While we're on the topic of 4.2, I just went on to the next problem, and I was emailing with a couple of people yesterday about number 2. In number 2, in 4.2, the question says, find a specific vector in the null space. In null space of A, oops, I didn't realize I was that zoomed in, sorry about that. and then it gives you a vector, or a matrix, excuse me. I'll let it focus here. And so then it gives you a matrix that is 3 by 5. And so the way you do that is you solve AX equals 0. So you put A in a augmented matrix with 0. You do RREF, right? And then you solve for basic variables in terms of the free variables. Now, if you want a specific vector, you choose the values for the free variables. Any non-zero values for the free variables. Now, the reason I'm talking about this one specifically is not because of this. I was kind of assuming people could do this. The tricky part about this one is this problem, for some reason, wants you to enter at least 4 digits worth of the answer. And so when you enter your answer, and when you're doing calculations, enter at least 4 digits. Don't round until like 4 or 5 digits when you're doing it, and then round to at least 4, or else it's not going to take it. And again, I'm sorry for that. I really can't control that on this website. Unfortunately, this problem has that sort of ingrained in it, and I cannot figure out how to get rid of it. The other way to avoid that is just to use fractions. So if you're using a calculator to solve this thing and you row reduce it, you can just have it switch back over to fractions. Let me show you how to do that real quick, actually. So here's my calculator. I have one in here already. I already have a matrix. I'm going to row reduce it. This is actually this problem. I was doing it earlier. And you can see it gives you huge decimals in there. So what I'm saying is use at least 4 or 5 decimals when you're doing it, or you can change them to fractions by going to math. I'm going to press the math button. And then the very first thing says frac. And so if you just hit that and then hit enter again, it'll change all the answers, all the values in there to fractions. And then you can just use fractions and then enter the fractions, and it'll be easy. You won't have any decimals to use because the fractions carry all the decimals with it. So that's another option for carrying decimals. Okay. Can I answer some other questions? What else is on your mind today? Yeah, Joseph, I actually did talk about that when I showed people how to use the calculator, but there's so much stuff going on, and it's not the most important thing in the world, so it might have gotten tossed by the wayside. I apologize if that caused you some trouble. That's something you can do anytime you do something on the calculator, though. Like if you did, like, I don't know, 12 over 35, and you get a decimal, and you want to know what the fraction is, you can just change it to the fraction, right? That's just a nice way to do it anytime with anything on the calculator. Yeah, no, I knew you weren't trying to give me a hard time, but I do kind of show that. But then people are usually so scared of fractions. It's like in one ear out the other. At some point, I hope people like realize that fractions are much better than decimals. I try to really teach that in pre-calc, right? You carry all the decimals with you. I mean, just look at that one example I just did. I just pulled it out of nowhere. 12 over 35, or you could use like 10 decimals or whatever that is, right? Just use 12 over 35. So much better. And it's precise and it's exact. All right. Sorry, that was just a little rant there. Can I answer some other questions, though? Were there questions about the notes for today? I don't remember what exactly was assigned for today specifically. I should mention, too, that I believe I have all the videos are now available for the rest of the semester, and all the homework is posted. Did I make all the homework dates posted? I can't remember if I've edited them all. I think I did, though. I think I've taken us through the last day of class, yeah, 5/13, which would technically be after our exam. But that's okay. Yeah, everything I think is all set up, though. Let me just remind you again, in case you popped in late, I did email test corrections back, and all the test corrections are available for you to view online. So you can see specifically where you lost points, and then the solutions are on Blackboard. I'm happy to answer any questions about that with you one-on-one. Okay, kind of a quiet class. Anything else I can answer today? I mean, I know. Thank you for the people who sent me those questions ahead of time. That's always really nice that I'm able to print those out and have them in printed form. If there isn't anything else, I'm gonna go ahead and log off and post this video to YouTube. Have a great one.